Hi everybody, today we're going to talk about functions and function notation. In my view as an instructor, one of the most important concepts to any algebra course would be functions. So it's really important that you get how we write these, why we write these, and how to work with functions as we will continue to use them for the rest of the time we study algebra. So to talk about functions, we need to start with a different definition called a relation. A relation is any set of ordered pairs x, y. Two important things are said there. It's a pair, so it means I have to have two things, and order matters. So saying xy is different than saying yx, so you want to pay attention to what's said first, what's said second. The domain is the set of the first coordinates, so you put all the x's together, that becomes the domain. The range is the set of second coordinates, so all the y's together, there's your range. So let's take a couple quick examples of finding the domain and range. In A, I have the set of points 1, 2, 2, 4, 3, 6. The domain will be a set that has 1, 2, and 3, so I only use the first coordinates. The range is also a set. It's equal to 2, 4, and 6, which is the second coordinates. For my set B, I have the points 5, 8, 2, 8, 2, 3, 7, 1. My domain is 5, 2. 2 is set again. I'm not going to repeat it. And then 7. And then my range is 8. Then 8 is set again. Then I have a 3. And then I have a 1. So notice, order doesn't matter. It doesn't matter if I write 5, 2, 7, 2, 7, 5, 5, 7, 2, right? I just have to have those elements in my set. And repetition is not important, so we don't need to say the same element twice. So we can take relations and make it a little bit more strict. So a function is a relation in which every element of the domain corresponds to exactly one element of the range. If you want that a little easier, I would describe functions as being relations where you don't repeat the x term. Again, let's go back to our examples and see which one's a function, which one's not. So in A, I'm looking at my domain, 1 goes to 2, 2 goes to 4, 3 goes to 6, that's a function. I didn't see any repetition of the x's. In B, I had 5, 8, 2, 8, 2, 3, 7, 1. The 2, 8 and the 2, 3 repeats the x, and this is not a function. Then C, I have 0, 10, 4, 10, 25, 10. Now the y repeated, I had 10, 10, 10, but function says don't repeat x, so this is fine. I didn't repeat any of the x's, so this is a function. Let's do the same thing, but let's look at it as a table. So I'm looking through my table, 1, 2, 2, 7, 3, 3, 5, 8, 1, 9. I see the 1 at the first one and the 1 at the second one. They have different y values, which makes this not a function. My second set, negative 2 goes to 4, negative 5 goes to 8, 3 has 6, 2 has 2, 5 goes 1, no repetition of the x's, so this is a function. We use the notation y equals f of x to define a function. So this is read as y is a function of x. The letter x is the independent variable. The letter y, which can be interchanged to f of x, is the dependent variable. So x we plug in, the y or the f of x is the value we get out. Of course, we want to try that. So let's use the function f of x equals 5x plus 4. Then we're going to evaluate it when x is 3, when x is negative 2, and when x is 0. Notice I say evaluate, not solve. I'm not solving for the value of x. I know the value of x. The value of x is 3, and I want to find out what's the corresponding value of f of x. So I'm going to do 5 times 3 plus 4. 5 times 3 is 15, plus 4 gives me 19. With f of negative 2, I do 5 times negative 2 plus 4. Negative 10 plus 4 is negative 6. C says f of 0, I do 5 times 0 plus 4. 5 times 0 is 0 plus 4 gives me 4. I kind of think of this as this recipe that says whatever I give you for x, multiply it by 5, add 4. So it's very clear instructions of what you want to do with the number I give you. So let's say I didn't give you a number, but I gave you negative a. Then I'm going to do 5 times negative a plus 4. The only thing I can do to simplify that is put a negative in front of the 5, then I have a plus 4. E looks similar. It says negative f of a, but the value will be different. So notice I'm going to have negative, and then whatever f of a is. So let's do a bracket here. And to say f of a is 5 times a plus 4. Now this time, this negative outside the bracket needs to distribute to both the 5a and to the 4. So I get negative 5a and then minus 4. So there is a little difference between f of negative a and negative f of a for this particular example. F says do f of a plus h. So I'm going to go 5 times a plus h plus 4. I have 5 times a plus 5 times h plus 4. This doesn't simplify, that's okay. It's just getting used to the idea of doing whatever the function tells you to do. Let's switch the function. This time f of x is x squared plus 3x minus 3. I'm going to start with f of 0. I have 0 squared plus 3 times 0 minus 6. 0 squared is 0, 3 times 0 is 0, and then I have minus 6, so my answer is negative 6. The next one says f of negative 4, so I have negative 4 squared plus 3 times negative 4 minus 6. Negative 4 squared is 16, 3 times negative 4 is negative 12, then minus 6. 16 minus 12 is 4, 4 minus 6 gives me negative 2. Then I have f of 1, so I do 1 squared plus 3 times 1 minus 6. This is 1 plus 3 minus 6. That also gives me negative 2. Let's go back to that f of negative a. I have negative a squared plus 3 times negative a minus 6. I can simplify that to a squared minus 3a minus 6. Again, I'm going to do negative f of a, so I have negative a squared plus 3a minus 6. Remember to distribute that negative all the way through, so I have negative a squared minus 3a, now plus 6. Then the last one, f of a plus h. I'm going to give myself some space. This will be a little bigger. So I have a plus h squared plus 3 times a plus h minus 6. Most important thing here is this a plus h squared. You can either do a plus h times a plus h and distribute it all out, or you can remember this will be a squared plus 2ah plus h squared. So if you didn't remember the 2ah, make sure you do the multiplication and it will come out. Then I have plus 3a plus 3h minus 6. Now you look at that and it's really big, but we're actually done and nothing gets to be combined here. A squared doesn't have a matching term, neither does the 2ah, the a squared, 3a, 3h, or 6, so we're like, that's fine, we'll leave it alone. Let's turn that into a rational. So I have x plus 8 over x minus 4, and we're going to start at 0. So I have 0 plus 8 over 0 minus 4. 8 over negative 4 is negative 2. Then I have negative 2 plus 8 over negative 2 minus 4. Negative 2 plus 8 is 6. Negative 2 minus 4 is negative 6. I get negative 1. Then I have f of 3, so 3 plus 8 over 3 minus 4. This is 11 over negative 1 gives me negative 11. Let's go back to the negative a. This gives me negative a plus 8 over negative a minus 4. If I do negative f of a, I have negative a plus 8 over a minus 4. Now, if you decide you want to distribute this, I would only distribute it to the numerator, not to the numerator and denominator. You want to think of this as being like negative 1 over 1 times a plus 8 over a minus 4. So if you decide to do that next step, you would have minus a minus 8 over a minus 4. You do want to be careful. It would be okay to just leave the negative sign outside. Gives you the same answer. Then the a plus h, I have a plus h plus 8 over a plus h minus 4. So the idea, whatever I give you in the parentheses, you stick everywhere that it says x. This leads us to something called the difference quotient. So we're adding f of x plus h, we're subtracting f of x, and then we're dividing by h. So let's try that with the function 2x plus 5. So if I do f of x plus h, I have 2 times x plus h plus 5. I'm going to put that in brackets to show that's my first piece. Minus f of x is 2x plus 5. And I'm dividing by h. So you have to kind of think sometimes, why are we doing this? This really is like slope. Remember, we took the difference of two things, and that's what the difference quotient is. It's just kind of hidden the way we're looking at it right now. So let's expand that. 2 times x plus h is 2x plus 2h plus 5. I'm going to distribute this negative sign. I have minus 2x minus 5 all over h. Interestingly enough, a lot cancels right here. I have a positive 2x, a negative 2x. I have a positive 5, I have a negative 5. So when I end up with 2h over h, I notice the h's cancel, and I end up with 2. So it got really big to end up really small. So let's try that with a different function. This time I have x squared plus 3. So I'm going to start the same way. X plus h squared plus 3. I'm going to do brackets. Minus, I'll do brackets again, x squared plus 3 over h. So like we saw earlier, when I square a binomial, I get a trinomial. I have x squared plus 2xh plus h squared plus 3, then minus x squared minus 3 over h. Once again, we have some things that cancel. I have a positive x squared and a negative 1. I have a positive 3 and a negative 3. I have left 2xh plus h squared over h. You want to be careful right now and remember that everything is being divided by h. So it's not just the 2xh, it's not just the h squared, it's both things. So let's factor out an h. I have 2x plus h over h. That's a better way to cancel, that way you don't forget one of them. And our answer is 2x plus h. Again, it got a lot smaller once we went through all of our steps. So let's go back to a table and do some evaluation that way as well. So I have this big table with a lot of values, and I first want to start with evaluating f of 0. So I find 0 in the table, and it says f of x is negative 4. The next one says what happens when x is 7. So I go over to 7, and I see that f of 7 is 45. Then it flips around and says, well, what is x when f of x is 0? So now I'm looking through the f of x part, and I locate 0, and it says, well, x was 2. Let's try that with some words just to see how we would write notation. I have the amount of miles m in miles that an electric car, after being charged h hours, is given by m equals f of h. The electric car can go 187 miles after being charged for 4 hours. Express this as a function of f. So I would say m, which is my miles, is f of the number of hours. Well, my number of hours is given as 4. So this is f of 4 is equal to the miles, which was 187. You aren't solving anything here, you're just learning how to work with the expressions. And I know it comes off a little weird at times, so I wanted to take the time to say, what does that mean and how would we write it? So we're going to do a little bit with graphs right now, and mostly we just want to be able to tell when I look at a graph, is it a function, is it not a function? So the easiest way to tell by looking at it as a graph is to use a vertical line test. So the vertical line test says that the graph can only be intersected by a vertical line and at most one point. So for example, if I have this circle, I would say, is this a function? And the answer is no. I can draw a vertical line that crosses the graph in more than one point, so this is not a function. So let's try this next graph. It's really curvy, but when I start drawing vertical lines, I can see they only touch in one place, so the answer to this is yes. This kind of looks like a U that got kicked over. If I draw a line, you can see it crosses in more than one place, so this is not a function. Another thing we can do with a graph is talk about one-to-one functions. A function is one-to-one if and only if f of a equals f of b means a equals b. Basically, one-to-one says every x goes to exactly one y, and we have no repetition at all anymore. So everything is unique, a unique x to a unique y. When we look at that in a graph, we look at a horizontal line test. So the graph of a one-to-one function can only be intersected by a horizontal line and at most one point. Let's go back to some graphs and look at them. So we want to decide, is this a one-to-one function? In this, if I start drawing some lines, our answer is yes. I'm only intersecting once, so that makes it one-to-one. This one that looks like a U. I can draw a line and it crossed twice, so this is not one-to-one. This is just line. This is a one-to-one function. I can draw a bunch of horizontal lines and it only crosses once, so this is yes, one-to-one. So that brings us to the end of our introduction to functions. There is plenty more to come, but I like to break it into little parts so it's not overwhelming. I hope that is helpful. Make sure to come back to learn a lot more. Good luck.